Okay, so I took your questions here and looked on the sticky note and going over your question and answer review here. First question that I had somebody ask is, can you explain the law of large numbers? So the law of large numbers means this. It means over time, which can also be said as in the long run, we will observe a certain probability. So if they say a probability is 0.5, for example, the probability of getting heads or tails is 0.5, then what that means is the more times we toss a coin, so the longer we do in the long run or over time, the longer we toss a coin, the closer we will get to 0.5 or 50%. Now if we only toss a coin a couple times, we may not get 50%. But if we toss a coin 100,000 times, we're going to get very close to 50%, and that's what the law of large numbers says. Also, think about if we just roll one die. It has 6 faces on it. Each one's equally likely, so each number should happen about 1/6 of the time. If you only roll a die a couple times, then they're not all going to happen the same. You may roll a 6 3 times in a row. But if you roll a die, again, like 100,000 times or 10,000 times, then each number is going to start occurring at about the same amount. So it just means over time things will average out to what we expect them to be. And that's the law of large numbers. Okay? Another person put everything on their sticky note. My advice there would be to go over all the problems in the chapter that we've done and go over the tests and look through that before you take the test. That's probably your best shot there. Next person put, can you do a question about a tree diagram? Okay, so I will do one here. I'd like for you to follow along, and I'd actually like you to work this one yourself. So I'm going to give you the question, and then I'm going to give you some problems to go with it. So here's the question, and you need to put this down. This is your class work here for Wednesday, so go ahead and write it down on a piece of paper. I give you 10 seconds here to get the paper out. Okay, so 30% of people get the drug aspirin and the rest get a placebo. Of the ones who get aspirin, 80% feel better, and of the ones who get the placebo, 65% feel better. So draw a tree diagram. So first, it's got to be random. Okay, and the first way we're going to split them up is somebody gets aspirin and somebody gets a placebo. Okay, so the top line will be aspirin, and that's 30% of people get the aspirin, so 0.30. 70% of people get the placebo, so that's 0.70. Again, if 30% get aspirin, that's how I knew 70% get the placebo. Now, of the ones who get aspirin, 80% feel better. So aspirin is now going to break off into, they either feel better or we'll just put not. And it says 80% feel better, 0.80, which means 20% do not feel better. Okay, the placebo breaks off into 2 groups, feel better, and in the placebo it says 65% feel better, which means that 35% do not feel better if they take the placebo. Now, we want to multiply these probabilities to get our 4 numbers out here. So, to get the people who took aspirin and feel better, it's 0.3 times 0.8, and we get 0.24. Sorry, yeah. 0.3 times 0.8 is 0.24, and 0.3 times 0.2 is 0.06. That's how many took aspirin and don't feel better. The placebo 0.7 times 0.65. That's 0.455. And how many took the placebo and don't feel better? That's 0.7 times 0.35. It's 0.245. All those should add up to 1. Now, the probability of getting better is what B says. If I look at getting better, I have 0.24 that took the aspirin get better and 0.455 that took the placebo get better. So I'm going to add those up, and there's a 0.695 probability of getting better. Now, the last thing says, what's the probability that you took aspirin given that you got better? So if we're given that we got better, that means all we're looking at is the ones who got better, which is the 0.695, these two. How many of those took aspirin? That's 0.24. And so if we know that you got better, the probability that you took aspirin is 0.24 divided by 0.695, which is 0.345. And that's a tree diagram problem.